Hey there, it's Neil with FlexArm and FlexCNC coming at you from the 2019 EASTEC show out here in West Springfield, Massachusetts. We're showing off our brand new GRD FlexCNC G-Series 2004 high output machine. First time ever for a machine like this in the industry, especially at the EASTEC show. What's really unique about the machine, it's the largest gantry mill here at the entire show. We got a Cat 50 spindle on the machine, the gearbox with maximum torque output. And right here we're displaying multiple setups on the workbed. So again, another unique feature with our machine compared to many others is that we've got 1, 2, 3, 4 workpieces and setups on the machine at one time. So what we're going to show you here is a couple of demos. One's a big hole with deep hole drilling. Another one's a really unique technology called flow drilling. And we've got another big, large heat exchanger plate over here. And then finally, some really dynamic machining on the right. So come on in, get a look at the new next-gen controller. So the machine, the FlexCNC, equipped with the Delta Tau control, has a couple of really unique features. One being called indefinite look ahead. Is actually look ahead into the program and be intuitive as far as what kind of motion control is necessary or needed for that specific part. So if you see it here, what we're doing is taking a piece of roll bar stock and we're turning it into a little bit of a shoulder hook. And what we're showcasing is what we like to call dynamic machining or dynamic milling. It's a feature that's really a benefit of Mastercam or CAM software. So for us, you can see we're using a very small end mill. It's a 1/4 inch solid carbide, 4 flute end mill. And a lot of people would think that you have a large machine, you have a large part, and you want to get rid of that material, you would use a really thick or maybe a 3/4 inch end mill. But what we're doing is what's called radial chip thinning. And what that is you can see the bird's nest of chips that we're creating, but we want some really little chips, but we want a constant contact with the cutter. That way we can go a lot faster and move material at a greater rate. So it's all about your inches per minute of material removal. So a lot of people will think that it's all about hogging or taking large cuts, but it's really not true. You can get parts done a lot faster by using a method like this, where you have a smaller cutter and you can extend the tool life as well. Taking a look at the control. So here we've got the indefinite read ahead or look ahead capabilities. So what that means is the machine is intuitive enough to know how many lines it should look ahead to execute that tool path properly. So if we're just doing a simple linear mill, we're only going to really look ahead a few lines because we don't want to exasperate the capabilities of the controller or the CPU usage. So for this, we're doing some really dynamic tool paths. So we're looking ahead probably several hundred lines in this case. And again, with the help of Mastercam in our machine, we'll use what's called geometric intelligence. That way we can generate some very, very dynamic tool paths like this. So the machine knows exactly how fast it should accelerate or decelerate into a corner or around the radius, depending on the call out of the part. So you'll notice we're doing a very small part here. Then right next to it is another setup featuring a 3.5 inch diameter heat exchanger plate. So that's a part that would be very hard to do on many other enclosed machining centers. And what's very unique about our machine is we can access the bed while it's machining. We've got a standard set of light curtains. While we've got a 5-minute cycle time on the right side, the operator can be over here changing out parts, flipping it to putting a new part on, trimming in some new vices for the next job. That way that operator is constantly getting output out of the machine. Many people would achieve something like this with an expensive pallet changer, but for our machine it's just something standard, being that open bed. Also makes it very easy for material handling. and getting parts on and off the workbench. So we're finishing up the part here. We're doing a little bit of a finish pass to get a better surface finish of the part. So here we slowed down our RPM to about 1600. Then we've got a finished part. So we'll do the next part. We'll move right on over to the thermal drill. We'll get a really good close look. Beautiful parts, beautiful chips. You can see the colors just perfect, right where we want it. There's a little discoloration. So the discoloration in the chips means that that heat is evacuating with the chip. It's not staying in the tool, it's not staying in the part. That's exactly what we want. Here we'll go over, do a tool change. Then we'll grab the flow drill. So many people call it flow drill, form drill, thermal drill. It's all really the same thing. It's some older technology, about 30 years old, very popular in Europe, slowly starting to make its way over here to the United States. What you'll see is a tungsten carbide cone-shaped bit that actually will use friction to heat up material and extrude it through thin wall tube or pipe. So you'll see we'll begin spinning very fast. We'll get material red hot to where it's a malleable state, and we'll push it down through the material. So you'll see there's no chips, there's no material being removed. It actually just displaces it. That way, after these holes are created, when we go ahead and tap them, we'll have a better quality and better strength thread. So many people would tap this after they drill it. You'd maybe have 2 or 3 threads. And if you thermal drill it, you'd have 6 or 7. So you also notice that we're using a bit of a paste. That way we can get just the right amount of lubricity. Let's get another good look. That paste, make sure that we can get just enough lubricity to extend the tool life, but without too much. That way we can make sure we can still heat up the material. There's a good look. We've got one more demo. And this one's very fun. So here we've got a steel block, some A36 mild steel. What we're going to be doing is actually an inch and 11/32 hole, 2 inches deep, using the Allied Genesis XT high penetration drill. It's a carbide bit insert on the end of the drill. We can get a good look at the drill here. So that carbide bit has a very advanced coating, perfect for high penetration. Going very fast and taking a really big cut. So we're going to be doing about 1100 RPM with a 4 thou per rev chip load. And here we're going to be plunging through this steel, 2 inches deep, inch and 11/32 hole, about 9 seconds. So using the high pressure through spindle coolant really allows that tool to take a big cut when we're very deep in the material. And there you can see some very large hole making in no time. So guys, thanks for tuning in to the FlexCNC demo here at EASTEC 2019. Feel free to give us a shout for all your large part machining needs. 1-800-837-2503. Thanks.